All right, so 4.4 exponential and logarithmic equations. So the first type, so here. All right, so the first method that we can use when it comes to solving equations dealing with your exponential relationships. Notice here it's saying that if our bases are the same, notice that b to the m equal to b to the n. So if your bases are the same, then you can drop the bases and just have your exponents. And then you can solve from there. But once again, you can only do that if your bases are the same. So direction could be solve. And we have 2 to the 3x minus 8 power equal to 16. All right. So the goal here is to see if it's possible to make one of these bases look like the other. And I can do that by looking at the 16 and recognizing that 16 is 2 to the 4th power. So that means I'm looking at 2 to the 3x minus 8 equal 2 to the 4th. Now my bases are the same. And that means I can drop the bases. All right, make sure we're okay. Now from here, we can just solve our regular linear equation. By adding 8 to both sides. And that's 3x equal to 12. Now divided by 3. X is equal to 4. All right, questions on that first one? A lot of these problems in this section, there will be more than one way to solve them. And this is, just one method that we're looking at. But either way, you still should get the same answer. So now in this case, we notice we have a 27 and a 9. And I cannot write either one of them. I can't write the 27 as a 9 as far as powers are concerned. I cannot write the 9 as a 27 in reference to my powers, but I can write both of them in terms of 3. So 27 is 3 cubed. And 9 is 3 squared. All right. And then here, don't forget your power rules. Power means multiply exponents. So in other words, I can rewrite this as rewrite it that way, multiplying those exponents. And my bases are the same now, so I can drop them. There's 3 times x plus 3 equal to 2 times x minus 1. All right, so now we can just solve. Distribute the 3, distribute the 2. 3x plus 9, 2x minus 2. Subtract 2x from both sides. X plus 9 is equal to negative 2. Subtract 9. X is equal to negative 11. All right, questions. Next one, let's see. I guess if I want to entitle this last one, I don't think I'll put a title on it. So here, use the same base to solve. And then down here, using logs to solve. So just showing you how we can use the natural log or the common log to get access to x. You know, if x is in our exponent and we need access to the x, then we have to do different things in order to get access to the x. So let's see how that will help us. Directions, of course, would just be solved. Normally there are no hints on that. So if I have 4 to the x power equal to 15, and I want to solve, notice that's not 4 times x, that's 4 to the x power, so I need access to this x, and as long as it is in the exponential form, I can't get to it as far as solving. So what I would do is apply the natural log, or I can do common log, doesn't matter which one. Just remember, normally natural log, common log, or the logs that are in your calculator. So we apply the log to both sides. And what that allows is for us to be able to bring the x down front for using our not a product rule, power rule. There we go, using our power rule. So then that would be x natural log of 4 equal to natural log of 15. Now to solve, I can divide both sides by the natural log of 4. Remember, your goal is still to get x by itself. X is going to be equal to natural log of 15 over natural log of 4. And that would be approximately 1.95. Now, if they want the exact answer, then natural log of 15 over natural log of 4 would be your answer. But approximately it's 1.95. Also keep in mind, the natural logs do not cancel. You can't cancel out natural log over natural log and the 15 over 4 be your answer. That's an application. So natural log of 15 is a number and the natural log of 4 is another number. So yeah, that is how your answer would stand. All right. Questions. So for the next one, 10 to the x equal to 120,000. So in the last one, remember I said it didn't matter whether you use natural log or common log, you still get the same answer. Here, it would be to your best benefit to use the common log. Let me write it like this. Remember, we're applying it to both sides. All right, and since we have a base of 10, we use the common log. Now, if we had base E, then we would use the natural log. It would be in our best interest to use natural log. And the reason being is because this cancels for us and leaves us with just x. That goes back to our rules from yesterday. And that would be approximately 5.08. See if I can get that a little lower. All right, questions. All right, next one, we have 40 e to the 0.6x minus 3 equal to 237. So first thing we want to do So we want to isolate the term with x as an exponent. So we're talking about this term right here. We want to get that by itself. So that's 40e to the 0.6x minus 3 equal to 237. First thing we'll do is add 3 to both sides. 40e to the 0.6x equal to 240. And we divide by 40. Oh. All right, so it's not, it should be 6. All right, so now we have e to the 0.6x equal to 6. And we add 3 to both sides and then divide by 40. And now, write this. I'm going to apply the natural log and bring it down some. To both sides. All right, so since we have base e, we're going to use the natural log. That's what ln is for us. And just like the other one, that will cancel and leave us with 0.6x equal to a natural log of 6. All right, so now go ahead and solve. Divide both sides by 0.6. X is equal to natural log of 6 over 0.6, which is approximately 2.99. You know, my math level, you know how many decimal places they want you to go out, you know, stuff like that. All right, any questions? Some questions may not be generated till you actually try the stuff out, which is fine. All right, so next one, 5 to the x minus 2 equal to 4 to the 2x plus 3. Once again, we need access to these exponents because that's where our x, our variable, lies. So we can apply log to both sides. If you want to do natural log, is fine. It doesn't matter which one. Once again, just make sure you do it to both sides. Only time it really matters is if you have a base e already in your equation, or if you have a base 10 already in the equation. So we're looking at natural log of 5 to the x minus 2, natural log of 4 to the 2x plus 3. So we take that x minus 2, bring it down front, take the 2x plus 3, bring it down front for our power, because of our power rule. So that's how we have it. Now the natural log of 5 and the natural log of 4 are actual numbers, so we can distribute into our parentheses. So I'm looking at x natural log of 5 minus 2 natural log of 5 equal to 2x natural log of 4 plus 3 natural log of 4. All right, so now, once again, we still have x in more than one place, but at least they're out of our exponent form now. So what we need to do is to get all of our terms with x to one side, all of our terms without x to the other. So we can add 2 natural log of 5 to take it over to the other side. And subtract 2x natural log of 4, take it to the left side. So this is going to cancel over here. This cancels over here. And that'll be x natural log of 5 minus 2x natural log of 4 equal to 2 natural log of 5 plus 3 natural log of 4. All right, questions, any questions? So now that we have all of our terms with x on one side of our equation, we can factor out x. All right. And now I can divide. Let me do this, make a separate one. I left the x in there, sorry about that. It should just be 2 natural log of 4. So now I can divide by the natural log of 5 minus 2 natural log of 4. That whole quantity cancels out on the left. And that leaves me with x equal to 2 natural log of 5 plus 3 natural log of 4 over natural log of 5 minus 2 natural log of 4. And that is approximately negative 6.34. All right, questions. All right, so let's do another scenario. All right, so we have e to the 2x minus 4, e to the x plus 3. That's going to be equal to 0. So what we have right here is a, let's say, quadratic. We have a quadratic scenario here. And what I mean by that is when I look at e to the 2x, that's the same thing as e to the x squared. And if you don't see the relationship, let's say if I let u be equal to e to the x, then this equation will look like this. You got u squared minus 4u plus 3 equal to 0. So you see we have an equation in quadratic form. All right. So if that's the case, we can just solve it quadratically. In other words, whatever method you would use to solve a quadratic equation, we can go ahead and use it. So I will go ahead and factor this. Set each part equal to 0. Now, you know, you don't have to use u or u substitution in order to do this. If you see the relationship, then feel free to flow with it. But you do stuff like this to help you see, you know, the connection and the relationship. So we have u equal to 3 and u equal to 1. Remember, that came from letting u be equal to e to the x, just to help us see the quadratic relationship and solve quadratically. So now we need to sub u to the x, not u to the x, e to the x back in. And so it's going to be e to the x equal to 3, e to the x equal to 1. And just like before, we will apply the natural log to both sides. And you know that is a 1. Try not to confuse it with my L's. And we know that natural log and that e will cancel on that left side, leaving us with just x. So x is equal to natural log of 3. Natural log of 3 approximately, I believe it's 110. Let me see. Yeah. And then the natural log of 1 is 0. Remember, the log of 1, no matter what the base is, 0. All right, questions? Any questions? right, a couple more scenarios. Let's go here. Log form to exponential. Yeah. All right, so that just means, or they're just reinforcing one of the first relationships that we saw between, or the first relationship that we saw between the log and the exponential form. Log base b of x is equal to y. That means b to the y is equal to x. So we can still use that relationship to solve if it's beneficial. So here we have log base 4 of x plus 3 is equal to 2. So if I want to transfer this log relationship to the exponential form, or the log form to the exponential form, I can rewrite it with my base being 4, because my base always stay the same. Then it's going to be 2 as my exponent equal to x plus 3. So we rewrote it in exponent form. All right, so let's go ahead and solve. Once you have it this way, then you can just solve. 4 squared is 16. Then subtract 3 from both sides. X is equal to 13. All right. Questions before we look at the next one? So next we have 3 natural log of 2x equal to 12, excuse me. And here we can divide both sides by 3 first. That'll be natural log of 2x equal to 4. Now, if we want to do what we did in the last problem, we recognize that natural log is log base e. So don't forget that. Just like common log is log base 10, natural log is log base e. So we can rewrite it as e to the 4th power equal to 2x. All right, to finish it off, we can divide by 2. X is equal to e to the 4th over 2. And that should be good enough. All right, we have 1, 2, just 2 more. here we have log base 2 of x plus log base 2 of x minus 7 equal to 3. All right, so here notice we have 2 logs and they both have the same base. So what we can do is condense the logs. And that goes back to remembering that whenever we're adding our logs with the same base, they can be rewritten with the multiplication of what they're being applied to. All right, so now we can rewrite in exponent form. So that's going to be 2 as our base to the third power equal to x times x minus 7. And now we can just solve our quadratic equation. That's going to be 2/3, which is 2 cubed, which is 8. And then distribute, which is x squared minus 7x. All right, now set one side equal to 0 by subtracting 8. X squared minus 7x minus 8 equal to 0. And we can solve by factoring. That's going to be x minus 8, x plus 1. So each part equals 0. X is equal to 8. X is equal to -1. All right, so after we get these two values, we do need to go back and look at our equation, make sure we check to see if we get valid solutions. And let's go back. What was our original equation? X2. Our original was log base 2 x plus log base 2 x minus 7 equal to 3. So if I were to do plug in x equal to 8, if I were to rewrite that 8, 2 to the third power, that's going to be 8 minus 1, which is 1. 8 minus 7, which is 1. Log base 2 of 2 to the third power is just 3. Log base 2 of 1 is 0. And we see 3 is equal to 3, 3 is equal to 3, which checks out for us. So x equal to 8 is fine. X equal to -1, we check that. we see this does not work. So can I take the log of a negative value? So the fact that x is negative has nothing to do with it. It's about when you plug it in. So in other words, let's say if I had log base 2 of 8 plus x. Well, when I plug in -1 here, then that would have been 8 plus -1, in which log wouldn't be applied to a negative value, it would be applied to a positive 7. So it's not necessarily about, I want us to get caught up in the fact that x is negative. It's about when you plug it in, are you taking the log of a negative value? And that would be the determining factor. So x equal to 8 is a solution. X equal to -1 is not. All right, so one more example for today, unless someone wants to see another one. So this one's one-to-one property for logs. The other one, it's very similar to the same base. Could have said one-to-one property for bases, but same type of thought process. If log is b, so if you have log base b of m equal to log base b of n, then you can drop your logs and you're just left with m equal to n. And just like before, when dealing with these logs, you need to make sure that you check them, like we did in the last one, because it's possible that one of these solutions may not work. So we have natural log of x plus 2 minus natural log of 4x plus 3 equal to natural log of 1 over x. So we're going to use the principle that was just mentioned above. Notice you have to have one solid log equal to one solid log. On this left side, we have two logs. So what we need to do is condense that expression into one. So subtraction means that we need to use division in the application. So there's going to be natural log of x plus 2 divided by 4x plus 3 equals to natural log of 1 over x. So we condensed. And now we can drop. All right, so we have x plus 2 over 4x plus 3 equal to 1 over x. All right, so we can cross multiply. It'll be x times x plus 2, 1 times 4x plus 3, x squared plus 2x equal to 4x plus 3. Now we can solve the quadratic equation by setting one side equal to 0. So 2x minus 4x is negative 2x. And at minus 3, we couldn't combine with anything. Go ahead and factor. Or if you decide to use the quadratic formula, you can do that. Either way, you'll get the same solutions. X is equal to 3. X is equal to negative 1. So what's going to end up happening here once you go and plug them in to do your check? 3 should work, and then negative 1 will not work. If nothing else, when you go back and plug in negative 1, there you go. When you plug in negative 1 right here and right here, it will give you the application or the log of a negative number. So if nothing else, check for that. Even if you don't check the whole check process, do the whole checking process. When you plug a negative right here, you will get a negative number. When you plug the negative right here, you also get a negative number. So if you're applying the log to any negative value, once you plug in, all it has to do is happen once in your equation, and that means that that solution would not work for you. All right. Questions on anything I've written? Any problems? Okay. So for next week, don't forget we're not having any official classes next week. If somebody wants to meet, then shoot me an email. But there are no classes next week. I figure I'd give you guys the opportunity to get ready for Thanksgiving, get ready for try to figure out Thanksgiving and all that, and also get the opportunity to get caught up and get into your work without having to worry about having class. So no classes next week, but once again, if you have questions, you can always email me, or if you do want to set up a time to meet outside of regular scheduled class, you can do that as well. And so I was just looking at the chat. So so I'm free. As long as you're not trying to meet on Thanksgiving, I'm good to go. So just let me know. Outside of that, I will see you guys on, I think, November 30th is the next time. It's not next Monday, but the Monday after next, November 30th will be the next time I see you guys. So if you guys are good, I'm good. Have a great weekend and all the good stuff, and I will see you next class. Same to you. Happy holidays to you as well.